Go ahead and take a look at number 12 from the midterm review. First two are limit problems. You can see the algebra that I completed to get there. And of course, you may have other ways of writing the notation of how, especially this first one, or how you go about doing it, because there are, again, some different processes or techniques people use to simplify these expressions. So in the first one, though, we're looking for the limit as x approaches infinity, which I want to remind you of that definition. If the limit does exist of a function as x approaches infinity, then we're really looking at the horizontal asymptotes, right? Where does this level off? If there is a limit value, then it's leveling off somewhere at some y value. So if you graph this, you would be able to see that it limits off. You have this horizontal asymptote at 1/3. Now, algebraically, what is the kind of the trick you use? And so I've highlighted this one piece right here, the square root of x squared over x, right? Using that idea that that equals the square root of x squared over x equals 1. Remember, so one of the great things in mathematics that we do many times is we multiply expressions or equations by 1 because it helps us rewrite those expressions, but at the same time, we rewrite them and it allows us to multiply or divide things by 1, and which doesn't ultimately change they're equivalent, right? When you multiply by 1, anything by 1 is itself, but we're doing it in a creative manner like that. So what we see in this problem here is that the x squared, right? We have this process when we're looking for the asymptote here, that we would divide. One algebraic technique is to divide everything by, right, looking at the highest power, which you think it's x squared, but it's really x because the square root of x squared is x. Technically, we can say that equals 1. We're looking at the positive side. And so when we do that, this is the algebra that emerges. Because another thing you can think about is that we're really multiplying both sides by 1 over the square root of x squared. And so that's that distributed, which is giving this here, over 1 over x. Again, those are equivalent when we think about it. As we look as x approaches positive infinity, these would be equivalent answers. 1 over x equals 1 over x. So that's what we're doing. We're multiplying by 1, which turns out to be here. And then we end up simplifying, right? You end up just getting these coefficients. And then as x approaches infinity, this is 0, that's 0, this is 1. This is 3, and that's where you get your square root of 1/3. But again, a technique that you need to be aware of rewriting this, the square root trick here. The next one is just looking at one shortcut is, you may have learned, is just to look at the ratio when they're equal to each other. Look at the ratio of the highest powers, right? And so it's 1 over 1. So you may have learned that. That's one way. Here's the algebra again. We're dividing everything by x squared, and then you take the limit as x approaches infinity, right? And these are 1s and these are 0s here. And notice I keep the limit notation there. It's important there to let me know you're calculating the limit all the way through. And then the last piece, if possible, find c that makes f of x continuous for all x. If not, explain why. So in this case, for these two pieces, right, this little linear equation and a quadratic, you see the x squared, for that to be continuous, they need a connect. Now, we're not talking about differentiable, we're just talking about continuous. So somewhere along 1, 2, 3, 4, 5, somewhere along 5, right, x equals 5, somehow these lines need to connect with each other in some way, the line and the parabola. And so what you do is you substitute 5 into x, and you set them equal to each other, because we're going to try to see, is there any value where those two pieces would be equal to each other at x equals 5? And that's what we do when you solve. So that was pretty straightforward.